Hello, everyone. Thank you for joining us in the gRPC Meetup. My name is Joe. I'm a software engineer in the Dataproc Metastore team. So for us, we are all users of gRPC. So today we will talk about our experience. How do we replace the old Apache Thrift RPC endpoint with gRPC? And how did we build new application based on that? At first, I guess, because maybe not everyone is familiar with a Hive or Hive Metastore, so I would like to briefly introduce this product. Hive Metastore is a de facto metadata service in the open source data analytics ecosystem. So in this ecosystem, we have, for example, Hive, Presto, Spark, so those software, and also Hadoop, like this. So what's stored inside Hive Metastore is the metadata. For example, database, tables, schema, partition, statistic information. So with the information of database and tables, for example, when you have a lot of files in some directories, and when you use Spark to run a job to process the data, you need to tell Spark which database, which table are you processing it, and the information of location, and also what's how your data looks like. The schema is stored in this metastore. So Spark need to use a RPC call to this metastore to get this information back. And there are other metadata, for example, partitions, statistics. Those are used to make your query faster and process less data, process only the necessary data. So this API is currently Apache Thrift. And this API is what is used by all the interface defined here, Hive, Presto, Spark. The architecture of Hive Metastore looks like this. So as I mentioned, it has a Thrift server. The interface is Thrift, and there is a Metastore server, which is a stateless RPC server. And all the metadata is stored in a relational database, which you can see on the right side, the DPMS. And the database and the server together becomes the Hive Metastore. And the Hive, Spark, Presto, they will read metadata or write metadata from the Thrift interface. So we have a lot of pain points using Thrift actually today. Because this is a product like built decades ago. At that time, maybe Thrift is the most popular RPC endpoint, and gRPC is a beginner. So almost all the Apache ecosystem are not using gRPC. But today, when we look at how Thrift is used here, we identified limitations. For example, Thrift does not support streaming APIs. Like decades ago, metadata here, as you can see, is just like information of database tables. They are not the real data. Data is very big, but metadata is small. But today, things has been changed. The metadata itself, it becomes very big because data is bigger and bigger. So even a read to the metastore will return a lot of results. For example, it will return thousands of partitions. It's a huge payload. So if we have streaming API, it would be very helpful to improve the performance, but unfortunately, it's not available in Thrift. And also, Thrift, we cannot use it together with serverless platform. In the previous diagram, as we say, there is a stateless backend server behind a relational database. On that server, we deployed it on GKE today, but in future, we would like to improve our infrastructure to use serverless platforms. So we plan to use Cloud Run, but unfortunately, Cloud Run only supports gRPC and HTTP, which is a blocker from deploying it on Cloud Run today. So this is one limitation of Thrift. And there is another limitation is from the identity and access aspect. So today, Thrift does not have an integrated solution for authorization and authentication. It asks the users to use self-managed approaches, for example, Kerbals and LDAP. For example, then customers need to set up those authorization by themselves. They need to, for example, have a Kerberos K distribution center or LDAP server, which is very complex and not secure. What is missing here is that the RPC tool does not have a fully managed authorization or authentication solution. And in future, we also plan to have better identity and access. For example, based on which RPC method you call, we verify your identity according to different permissions. For example, if you are access different database, we will check whether you have permissions on this database. So all those complex authentication approach, we don't have a good way to build it in Thrift today. For those reasons, we decide to invest to migrate to gRPC. Here are a few benefits we identified when we do the migration. First is high performance. It uses HTTP2 and Protobuf 3. It has built-in authentication support, and it's token-based authentication approach. And also it has SSL and TLS, ATLS, and so many of those approaches, they are compatible with cloud-native authentication frameworks. For example, on Google Cloud, we have IAM, which is an integrated managed authentication framework. If we can let user use IAM, they will be very secure and they don't need to deploy any authentication layer by themselves. And also we identify it's very easy to extend the functionalities through the interceptor API of gRPC. I will show how it is useful later in our applications. Also, gRPC is better supported by service mesh, for example, Istio, because as a cloud service, we have Metastore, Hive Metastore's endpoint exposed to customers, but that endpoint is not directly exposed to customers. We have a layer behind, ahead of it, so which we use Istio. But Thrift does not have the best support with Thrift, so gRPC is still the best here. And also, as mentioned, gRPC is better integrated with Cloud Run, which is a serverless platform to deploy servers. Also, it supports streaming and streaming requests and responses. So with all of those benefits, we integrate Hive Metastore with gRPC, and we build a few new applications. For example, Cloud Run endpoint. So we expose a gRPC endpoint, which is public on Cloud Run for our users. And we have implemented fine-grained IAM control and also metadata federation, which is a single endpoint that you can connect the different Metastore in the back. So here is how we do the gRPC integration. So this is actually very hard for us because in Thrift Hive Metastore, so the Thrift RPC interface, it has over 100 methods. If we want to replace it by gRPC, we need to rewrite the Intel server, which is a huge amount of work. And another issue is that the whole ecosystem is using this Thrift interface. If we change it to gRPC, our client cannot use it because they are client, they are Thrift client. In the Thrift client, they are integrated in Presto in Spark. And also, we don't want to introduce a huge change to the upstream open source world to replace it Thrift entirely by gRPC. So we want to do it step by step. So in the first step, we didn't change any code in Thrift Hive Metastore. Instead, we decided to build proxies. We deploy a proxy on the client side, and we deploy another proxy on the server side. For example, as you can see in the first picture, the upper one, on the left hand, I have a gRPC client. On the right hand, I have a Thrift server. So how can this Thrift server talk with this gRPC client? So the solution is that we deploy a proxy sitting together with the server. When the gRPC client sends it a gRPC request, this proxy translates the gRPC client request to a Thrift request, and the Thrift request is processed by the server returns a Thrift response. The proxy again translated back to gRPC response and give it back to the client. Then to this client, the proxy together with the server the two behave like a single gRPC server. So this is the proxy on the server side. So on the client side, the same. Actually, today we only have Thrift client. But if we run a proxy sitting together with the client and it do Thrift gRPC translation, then a Thrift client can work together with a gRPC server. So we need two proxies, and then you can imagine the local communication between client proxy and the local communication between server proxy. They are still Thrift, but the communication between the two proxies on the public internet now becomes gRPC. So here is the idea of the proxy. So now you can see we don't need to change any code of the Thrift server, but now we can make the communication gRPC. Here is how we implement the proxy. There are three steps. So on the left side, you can see this is the Thrift spec of the struct. On the right side, this is equivalent gRPC struct. And the first step is that we manually add an equivalent gRPC interface. We define every RPC method. So there are over hundreds of those methods, and as well as their request and response in protobuf. They need to do it one time manually. But Hive Metastore has different versions, so we did it for each Hive Metastore. And the second step is happening at runtime. So we use a library called MapStruct. It's a mapper of Java objects. So we use it to build the core of the proxy. Every time we receive a Thrift Java object, for example, a request, we use this MapStruct to map it to a gRPC request and send it out. And in most of the time, it can do the mapping automatically, but there are corner cases. For example, in Thrift, we can define a list of objects as a key, but it's not possible in gRPC. So in this case, we will define a new gRPC interface, and we will manually rewrite the MapStruct to do the conversion. The third step is that because in the proxy and the Thrift and the gRPC proxy, it's listening on Thrift request or listening on gRPC request. So we need a Thrift server or gRPC server. And this server, we don't want to write this server manually because it has hundreds of methods, hundreds of handler functions to write. So we use Mestash. It's a templating code generation tool that we use a template to generate all the code once. So with all those three steps, we can build the proxy. And now we have the proxy, how to deploy it. We have actually a few different phases. The phase one is the simplest. We just running those proxy outside Hive Metastore. This is what we do today. So in future, we plan to push it to Hive Metastore open source. The solution is like this plot. When the customer talks to Hive Metastore today, it will forward all the traffic to a Hive Metastore Thrift server, and it will forward the traffic to the backend relational database. So the next step, we plan to add a configuration. And if the configuration says it will use gRPC, then it will launch a new Hive Metastore gRPC server. And the front-end server here will route all actually the proxy. And the proxy will translate it to a Thrift and give the Thrift request to the original Thrift server. So this approach, we pushed the proxy into Hive Metastore, but it's still a proxy. So the final step, we plan to throw away this Thrift server and use only this gRPC server, or make this gRPC server the primary server and use a proxy when people need to use Thrift server for backward compatibility. And we have a Hive proposal here, so which is the work we are currently working on to make it open source. Okay, so next I plan to have a demo about how this proxy works. Let me open the demo file. Okay. So I would like to introduce the tools that I use this demo a little bit. I use Google Cloud Platform, and I use a service called Dataproc. So Dataproc is a managed service running Spark, Hive, Hadoop, Presto, all those Apache or open source data processing tools on Google Cloud. Now I will play this demo. In this demo, we will use gRPC proxy to connect a Dataproc cluster to a Hive Metastore. I already created the resources that we will use in the demo. First, we have a Dataproc cluster called gRPC demo. It has a master node and no worker node because we don't need the worker node for this demo. And I already use SSH to log into this master node and open the two windows here. Also, I have created a Dataproc Metastore service which runs a Hive Metastore. It exposed a URI, a Thrift endpoint here, and I already connect the Dataproc cluster to this Hive Metastore. So if I take a look at the Hive configuration on this Dataproc cluster, we can see that the Hive Metastore URIs is the same as the IP here, which means that it will use this Hive Metastore. In order to verify it, let's open a new Hive session. At the same time, I opened the backend log of this Hive Metastore. So first, let's take a look at the databases that we have. It only has the default one. So let's create a new database called gRPC demo 1. And we can use this to quickly test that we are using this Hive Metastore by checking whether this database will be seen in the log here. So let me refresh the log. And you can see that the create database request has been printed here, which means that the connection is successful and we are using this Hive Metastore. And we can verify the name gRPC demo 1 here. So this is basically how it works for Thrift connection. Now let's demo how to use a gRPC proxy to do the same thing. So let me close this session. So the first step is to create the server-side gRPC proxy. I use Cloud Run to do this. So Cloud Run is a serverless platform that I can run a Docker image. And so this is my Docker image, which is the proxy. And after deploying it, it will be listening on a URI here for gRPC request. And once it receives any gRPC request, it will convert them to Thrift requests and forward it to a Hive Metastore. The Hive Metastore Thrift endpoint is specified here. You can see this is the same Thrift endpoint of the Hive Metastore we just used. So with this Cloud Run service and the Hive Metastore service, we actually get a new gRPC Hive Metastore service because it will be listening on gRPC Hive Metastore request. So this is half of the story. So the next step is to deploy a proxy on the client side. So the client is the Dataproc cluster here, this node. What we will do is that we will run a local proxy using this script. Let's take a look at this script. This is because we will use Docker to run this proxy. So this is Docker image. Similarly, it's the image of the proxy binary. This proxy will be listening on this Thrift port. Once it receives any Thrift request, it will forward it to this gRPC URI. which is the same as we deploy here. Now let's run this proxy. So the proxy is running now. Now we have a new Thrift endpoint, which is this proxy. And the next step is change our Hive configuration to let Hive use this local proxy, local Thrift proxy, instead of the original remote Thrift endpoint. So it talks to localhost now. Let me restart Hive. During the initialization of this Hive session, it starts to talk to Hive Metastore. As you see, the proxy is getting requests. Okay, so the initialization is done. Let's show the database that we have. We see gRPC demo 1 here, which means that it's the same Hive Metastore we just used for the last step. So let me do the same thing, create a new database gRPC demo, call it gRPC demo 2. And you can see that the proxy received this request. And we can see on the log that it printed. So this log is for the command that we just ran. It's for create database gRPC demo 2, which means that on Hive, when we create database, it sends out a Thrift request and the proxy received it. And then it sends this request to the gRPC request to this Cloud Run proxy. And this proxy forwarded to the server, which is finally this Hive Metastore. And we can verify on the Hive Metastore, do we receive this request? So you can see here, another database, gRPC demo 2, create database request is received here. So this is how gRPC proxy works. So as you see, with this local proxy, now this Hive start to use a gRPC client to send out gRPC Hive Metastore request. And together with this proxy on the server side, this Hive Metastore becomes a new Hive Metastore, which exposes a gRPC endpoint, which is this one. So the network connection in between the client and the server is not gRPC instead of Thrift. Okay, let me jump back to the original presentation. So in the previous demo, I showed how the proxy idea I described works in our product. And now the next slide is now we have gRPC now. How do we build a new application when we have the superpower of gRPC? So the important features that we build is I give an example here called fine-grained IAM access control and public cloud endpoint. So before we have gRPC, when we only have Thrift, so what we do is that there's no enforced access control in Hive Metastore. It means that if you have the IP, if you can access the Thrift endpoint, assuming that you are not deploying, for example, Kerberos or LDAP server, so then everyone can access the endpoint. So in order to protect the endpoint from others, because you can imagine the Hive Metastore actually store all the metadata of an organization. So the data security is very important. What we do is that we hide this IP inside a private network, which means that outside this VPC network, no one can access it. So this is how we protect it. But there are a lot of complexities using this infrastructure. The issue is that when using private IP, we need to do IP peering because all of our resource is not created in the customer visible customer project. we created all the resources in a hidden tenant project. So in the customer's view, they only see that I created the resource, it gives us a Thrift endpoint. The customer don't need to worry about all the resources. So, but in this way, we need a VPC peering. And we also need to do IP reservation in the customer's project. And another solution without VPC peering is called a private service connect. But either way, we need to do a lot of network work. But now, after having gRPC, our status now is that we expose a public endpoint. So this endpoint is public. Everyone can access it. There's no restriction of private IP, but the access is protected by IAM. It means that when someone access some resource, we will check this permission. For example, it can apply to database or tables, and the permissions are like create, delete, update, get list, set IAM policy, and get IAM policy. So this is the fine-grained IAM access control. And this permission can be granted to users, to groups, or to service accounts. So how do we implement it is exactly the gRPC proxy. Now we deploy the gRPC Thrift proxy on a Cloud Run. So the Cloud Run can give the user a public endpoint. And on the customer side, most of our customers, they are using Dataproc on Google Cloud. So on the virtual machine of Dataproc, we will pre-install and run the Thrift proxy. So customers don't need to do anything. And for external customers who don't use Dataproc cluster, we are working on like releasing this to the public so everyone can run the Thrift proxy by themselves. For this IAM, fine-grained IAM access control, we use the gRPC interceptor, and it will check the user's token and forward the token to the IAM service to check this permission, and it will deny the service if the corner don't have the permission. Okay, this is all I have today. So to summarize, in this talk, we enhance Hive Metastore with gRPC integration, and we enable new features on it. For example, fine-grained IAM, Cloud Run endpoint, and Metastore federation, which I don't give detail here. And in future, there are actually still a long way to go because Thrift is still used in the Metastore core. We only build a proxy now. So the communication between the proxy and the server is still unscalable for a huge request. And the proxy itself introduced additional latency. So the long-term solution is still to completely replace Thrift by gRPC. That's all I have.